Hi students, today I will explain one of the important topic, that is the isotopes, isobars, isotones and isodiaphers. First of all, what is the isotope? Just see here the definition of an isotope. Isotopes of an element are the atoms of the element with the same atomic number but different mass number. So same atomic number and the different mass number is called as the isotopes. For example, here the chlorine 1735, chlorine 1737, both are the same atomic number but different mass number. In the chlorine 1735, number of neutrons are the 18. How can we are getting the number of neutron? From mass number to we are reduce the atomic number. We are getting the 18 is the number of neutrons of chlorine. And number of electrons or atomic number is equal to the number of electrons, that's why it's the 17. And number of protons are the 17. Whereas in the chlorine 1737, chlorine atomic number is the 17 and mass number is the 37. And number of neutrons are 37 minus 17, it is the 20. Number of electrons are the 17 and number of protons are the 17. Now the chlorine atomic weight is the 35.5. How can we are getting the atomic weight of the chlorine? Just here I am taking average of two isotopes. For example, chlorine 1735 isotope is available only 75%. And chlorine 1737 is available at 25%. Now chlorine 1735 isotope percentage is 75 into 35 plus chlorine 1737 isotope percentage is 25. It is a 25 into 37. So percentage always I am taking by 100. So now the atomic weight is the 35.5. That is the chlorine atomic weight. So isotopes is nothing but the atomic number is the same and the mass number is the different. So one more example, H11, H12 and H13. Here the hydrogen, they have the same atomic number and different mass number. It is called the protonium and it is the deuterium and it is the tritium. So once you can look at here, in the year of 2019 mains, they are asking one of the question, the isotope of the hydrogen are protonium, deuterium and tritium. Okay students, this is about the isotope concept. Next one is isobars. The atom of the element which have same mass number but different atomic number are called as the isobar. So here same mass number is the same and atomic number is the different is the atomic number. It is called as the isobars. For example, here I am taking H13 and helium 23, H113 isotope and helium 23 isotopes, and here the mass numbers are the same but the atomic numbers are the different. And here in the H13 the number of protons are the 1. It is the number of proton, atomic number of protons are the 1, and the number of electrons also it is the 1, number of electrons also 1, and number of neutrons are 2. Now the mass number is equal to the number of protons plus the number of neutron, 1 plus 2, that is the 3 is the mass number. Whereas in the helium, and here the number of protons are the 2, it is the number of protons, that the atomic number is the number of proton, and the number of electrons are 2. Why? Because in the neutral atom, how many number of protons are present, that equal number of electrons are present, and the number of neutrons are the only 1. Why? Because from the mass number, it is here it is the mass number is a 3 and atomic number is a 2 and the number of neutrons are the only 1. From the mass number we are reduce the atomic number, we are get the number of neutrons, so it is the 1, and it is the one of the example of isobars. One more example is and potassium 1940 and calcium 2040. Calcium 2040, and here the potassium 1940 and second one is the calcium 2040, and here atomic number is the different but the mass number is the same, and it is also an example of isobars. And next one is the isotones. Isotones may be defined as the atom of different elements containing same number of neutrons. Different elements containing same number of neutrons. Here the neutrons are the same. Now we will discuss one of the example. For example, hydrogen 1,3. It is the protonium, and along with that helium 2,4, and here in the hydrogen 1,3 and helium 2,4. Now here the number of protons in the hydrogen is the 1, and the number of neutrons are the 2, and the number of electrons are the 1. Whereas in the helium the number of protons are the 2, and the number of neutrons are the 2, number of electrons are the 2. Then here from mass number to atomic number, and here the mass number of the hydrogen is the 3 minus 1, that equal to number of neutrons are the 2. Along with that helium mass number is the 4 and atomic number is the 2, and 4 minus 2, the number of neutrons are the 2. So different elements containing the same number of neutrons are called as the isotones. One more example. In the potassium 1939, whereas in the calcium 2040. In the potassium 1939, number of electrons, and here it is the 19, and the number of protons are the 19, and number of neutrons are 20. From the mass number to atomic number is the 20. Whereas in the calcium 2040, number of electrons are 20, and number of protons are, atomic number is the number of protons, it is the 20, and the number of neutrons are 40 minus 20, it is the number of neutrons are the 20. So different elements containing same number of the neutrons. So it is an example of isotones. Next one is the isodiaphers. The isodiaphers are the atoms of different elements which have the same difference of the number of neutrons and protons. Here the difference between the number of protons and the neutrons are the same. Those are called as the isodiaphers. For example, here I am taking two elements. First one is the boron 511 and second one is the carbon 613. First one is the boron 511 and second one is the carbon 613. In the boron 511, number of protons are equal to the atomic number, it is the 5, and the number of neutrons 11 minus 5, that is the 6 is the number of protons, and number of electrons are the atomic number is equal to number of electrons is the 5. Whereas in the carbon 613, number of protons are 6, atomic number is the 6, so the number of protons is the 6, and the number of electrons also 6, and the number of neutrons 13 minus 6, that equal to the 7. Now here the difference between the number of protons and the number of neutrons, so number of protons and the number of neutrons difference is, number of neutron and the number of proton difference is the only 1, and here also number of neutron and the number of proton difference is the only 1. Here number of neutrons are the 6 and the protons are the 5, and 6 minus 5, that is the 6, minus 5, it equal to 1. Whereas in the carbon 613, the number of protons are the 6 and number of neutrons are the 7. So 7 minus 6, that equal to 1. So here different elements which have the same difference in the number of neutrons and the number of protons are called as the isodiaphers. Next one is the isoelectronic species. Isoelectronic species meaning the species are the elements or the ions that have the same or the equal number of electrons. That's simply called, it is the isoelectronic species. For example, here I am taking one example: C-4, N-3, O-2, fluorine ion, neon, sodium plus and magnesium plus 2, and the aluminum plus 3 and silicon plus 4. And here the carbon atomic number is 6. In the carbon is gaining 4 electrons. So total number of electrons in the carbon is 6 and the carbon is gaining 4 electrons. So the number of electrons in the C-4 is the 10. Whereas in the N-3, the nitrogen atomic number is the 7. That meaning the nitrogen contains 7 electrons and nitrogen is gaining 3 more electrons. So the total number of electrons in the N-3 is the 10. Whereas in the O-2, the oxygen is gaining 2 more electrons and already oxygen is having 8 electrons. Total number of electrons are the 10. And the fluorine atomic number is the 9. And the fluorine contains 9 electrons and it is gaining 1 electron. So total number of electrons are the 10. Whereas the neon atomic number is the 10. That's why the number of electrons also 10. Sodium atomic number is the 11. But the sodium is losing 1 more electron. That's why the total number of electrons in the sodium plus is the 10. Whereas in the magnesium plus 2, it contains the magnesium contain the atomic number is the 12, but losing 2 electrons. That's why atomic number of electrons in the magnesium is the 10. Whereas the aluminum atomic number is the 13. So number of electrons is the 13. But here the aluminum losing 3 more electrons. That's why the number of electrons in the aluminum is the 10. Whereas in the silicon atomic number is the 14. But the silicon is losing 4 electrons. That's why total number of electrons in the silicon is the 10. So different ions are having same number of electrons. Those are called as the isoelectronic species. And one more example, water and ammonia. In the water, the hydrogen, each hydrogen containing 1 electron. So the total number of hydrogens are the 2. So that's why 2 electrons. And oxygen containing 8 electrons. 2 plus 8. Total electrons are the 10. Whereas the ammonia, nitrogen containing 7 electrons. Whereas 3 hydrogen containing 3 electrons. Total number of electrons are the 10. So different compounds containing the same number of electrons. These are called as the isoelectronic species. Thank you, students. If you like my video, give me the like and don't forget to subscribe my channel. Thank you.